Welcome. Have you ever looked at a big 14-mark exam question and just thought, where do I even begin? Well, in this explainer, we're going to break down question 2 from the AQA GCSE Physics Paper 2. We'll use the official mark scheme to show you exactly how every single one of those marks is won.
Okay, let's dive right in. So, the whole setup here is a young child using a baby walker. Now, it might seem pretty simple, but this is a classic exam move, using a familiar, everyday situation to test some really fundamental physics principles.
So here's how we're going to approach this. We'll go through it step by step, part by part, exactly like you would in a real exam. We'll kick off with resultant force, then jump into calculating work done, take a look at how forces can change speed, and wrap it all up with moments and gears.
All right, first up, we've got a 2-mark question. It's all about the forces at play on the child when they are standing perfectly still.
So, take a look at the question. See how it's asking for two things? First, a value, and then a reason. This is such a classic AQA style. It's designed to check if you not only know the fact, but you actually understand why. Let's see what the mark scheme is looking for.
Right, so how do you actually get these marks? Well, the first one is a piece of cake. Just for stating the resultant force is 0 newtons. Bam, 1 mark. But, and this is important, the second mark is linked. You only get it if you give a valid reason why, and the mark scheme gives you a few options. You can say the child isn't accelerating, or that the upwards and downwards forces are equal, or even just say the forces are balanced. Any of those will get you that second point.
Okay, moving on. The question now pivots a bit. We're moving away from pure concepts and into some actual calculations, focusing specifically on work done.
And first up, honestly, this is a gift, a free mark. All you have to do is write down the correct equation from your formula sheet. Work done equals force times distance, or just W equals F times S, gets you the point. Never, ever skip these easy wins. Okay, so now we've got to actually use that equation we just wrote down. They've given us the work done, which is 35 joules, and the distance, 2.8 meters. We just need to find the force. Now listen, if you want all 3 marks, and you definitely do, the absolute key is to show you're working. Let's see how that's done.
And this is a fantastic breakdown of how they award marks for these calculation questions. You get a mark just for plugging the numbers into the right spots. You get another mark for rearranging the equation correctly to find F. And then, finally, the last mark is for getting that correct answer, 12.5 newtons. And check this out, the mark scheme even lets you have 13, so there's a little bit of wiggle room with rounding.
All right, now things get a little more interesting. The scenario changes up. The kid moves the walker from a carpet onto a hard floor, and suddenly, the speed changes. Our job? To explain the physics behind why that happens.
So here we go again, another 2-mark explain question. Quick tip, whenever you see that word, explain, it's a signal. It means you can't just state a fact. You have to connect the dots and show a logical link from cause to effect.
So check it out. It's a simple 2-step logical chain. For your first mark, you just need to state that the resistive force, or friction, has gone down because of the hard floor. For the second mark, you have to connect that to the resultant force. If the child is pushing with the same force, but the friction fighting against them is smaller, then the overall resultant force gets bigger. And a bigger resultant force means acceleration. You need both of those points to get the full 2 marks.
Okay, we are on the home stretch now, the final part of the question. And the focus is going to shift completely over to those little toy gears on the front of the walker, bringing in ideas about moments and rotation.
All right, let's really look at this diagram they've given us. You've got the big one, gear A, and the smaller one, gear B. And see that? There's a force being pushed right on the edge of gear A, a certain distance from the middle pivot point. That's all the info we need for these next few questions. And would you look at that? Just like before, they're basically handing us a free mark on a silver platter. All you have to do is write down the right equation for the moment of a force. Moment equals force times distance, or M equals F times D. Easy. Time for another calculation. Now this one looks super straightforward, but hang on. There is a classic trap here that catches so many people out, and it is all about the units they've given you in the question. Just look at this. The first mark you get isn't even for the math. It's for converting the units correctly. You absolutely have to change those 7.5 centimeters into 0.075 meters before you even think about multiplying. It's such a common mistake to make, so always check your units are standard SI units. Once you've done that, it's the same old pattern, 1 mark for substitution and 1 for the final answer of 0.15 Newton meters.
All right, here we are, the last 2 marks. And guess what? It's another explain question. So we know the drill by now. We need to state what happens and then explain why it happens. Let's see what the mark scheme wants.
So what's cool here is that the mark scheme gives you a bit of choice for that first point. You get the what mark for describing gear B's motion. You could say it rotates in the opposite direction, or clockwise, or even that it rotates faster. Any of those works. But for the second mark, you got to bring the physics. You have to explain why it's happening. Because gear A is exerting a force on gear B, or because it's creating a moment on gear B.
And just like that, we've done it. All 14 marks decoded. We've seen a bit of everything, right? Concepts, calculations, explanations. So before we finish up, let's quickly recap the big takeaways here. The strategies you can use on any physics question, not just this one.
Seriously, think back through the question we just smashed. We saw every single one of these strategies in action. Writing down the equations, that got us 2 easy marks. Showing all our working out, absolutely essential for those calculation points. That super important unit check in the moments question saved us from a really common error. And breaking down those explain questions into a clear what and why was the key to getting those final marks. These aren't just little tips, they're solid gold strategies that will seriously boost your score.
So I want to leave you with this final thought. Obviously, physics isn't just about baby walkers, right? These ideas, resultant force, work done, moments, they are everywhere. Think about pushing a shopping cart, riding a bike, even just opening a door. Where else can you spot these principles in action? Keep practicing, keep applying them, and you will absolutely master them for your exam and beyond.